Do you think you're living in the present? Think again. Look at your hand. The light that hits your skin takes a fraction of a nanosecond to reach your eyes. It's fast, but it's not instantaneous. Now look at the moon. You see it as it was a second and a half ago. Look at the sun. You are seeing a ghost from 8 minutes in the past. That bright spot in the night sky? He may have died 1,000 years ago, but the news hasn't reached us yet. We don't see the universe as it is. We see an archaeological map. The cosmos is a graveyard of light, and the distance between these ghosts, it's not just far. It's a distance that the human brain, evolved to hunt on the savannah and understand meters and kilometers, is biologically incapable of comprehending. Today we're going to break that barrier. We're going to travel to where mathematics ends and existential terror begins. Welcome to the true scale of light years. To understand distance, we first need to understand speed. And in our universe, to do this, subscribe to the channel and activate the notification bell so you don't miss any videos. Comment below what you think about the universe. There is a draconian law, a cosmic speed limit that nothing, absolutely nothing with mass, can transgress the speed of light. 300,000 kilometers per second. For us creatures trapped on the surface of a damp rock, this seems instantaneous. If you turn on a flashlight, the beam hits the wall before your neuron can process the action. In the blink of an eye, the light could circle the Earth 7.5 times. It's a divine speed. But when we leave the atmosphere and enter the dark arena of the cosmos, light ceases to be a swift god and transforms into something disturbingly slow, a cosmic snail crawling through the vastness. Let's do a thought experiment. Imagine you can fly at the speed of light. You become a photon. The universe is timeless for you. But for those observing you, you are the messenger of reality. You leave Earth heading towards the moon. The journey is ridiculous. You blink and you're already there, 1.5 seconds. That's why, in the recordings of the Apollo missions, there was that strange silence between Houston's question and Neil Armstrong's answer. That silence was physical distance transformed into time. The voice traveled at the speed of light, but the distance imposed a delay. Space creates solitude even at maximum speed. Now let's raise the stakes. Let's go for the sun. You, the traveler of light, take 8 minutes and 20 seconds to cross the chasm between Earth and our mother star. Think about what this means. If the sun exploded now or simply disappeared, extinguished by a giant cosmic hand, we here on Earth would continue our lives normally for another 8 minutes. We would see the sun shining in the sky, feel its warmth on our skin. The plants would continue photosynthesizing. We would be orbiting nothingness, warmed by a ghost, ignorant of our impending end. Gravity also travels at the speed of light. Earth wouldn't know the sun had disappeared until the last wave of light and gravity arrived. We live in perpetual delay. The universal now doesn't exist. What you call now is just your local slice of time. Let's continue our journey. We've passed by Mars, the red planet. At the speed of light, depending on the orbit, this can take anywhere from 3 to 22 minutes. Imagine trying to control a robot on Mars with a joystick. You move the control to the left. Eoscan, the robot, only receives the command 20 minutes later. If it was on the edge of a cliff, it will have already fallen long before you see the accident. Distance renders us powerless. We continued flying. We passed through the asteroid belt, crossed the majesty of Jupiter, about 43 light minutes away. We arrived at Saturn, after more than an hour of travel at the maximum speed allowed by the universe. And here the scale starts to become overwhelming. Pluto, the former 9th planet. To get there at the speed of light, it takes us about 5.5 hours. Imagine this, 5.5 hours traveling at 300,000 kilometers per second. If you were on Pluto and looked at Earth with an impossibly powerful telescope, you wouldn't see what's happening now. You would see what happened 5 hours ago. You would see people having lunch while on Earth they are already having dinner. But Pluto is just the frontier. The true boundary of our solar system isn't Pluto. It's the Oort cloud, the nursery of comets. To cross this region and finally escape the sun's gravitational influence, traveling at the speed of light wouldn't take us hours. It would take us almost 2 years. 2 years of uninterrupted light just to leave the house. And here is the coup de grace for our intuition, the nearest star, Proxima Centauri. She's our neighbor. On a cosmic scale, she's right there, If the universe were a city, the Sun and Proxima Centauri would be two apartments on the same floor. However, light, traveling at that mind-boggling speed that circles the Earth 7 times in 1 second, takes 4 years and 3 months to get there. Let's translate this to human technology, so we can feel the weight of impossibility. The Voyager 1 probe is the fastest object ever built by humanity. That is leaving the solar system. It travels at about 61,000 kilometers per hour. A revolver bullet travels at about 1,000 km/h. Voyager is 60 times faster than a bullet. If you were to board Voyager 1 today, heading towards Proxima Centauri, do you know how long it would take to reach our nearest neighbor? It wouldn't be 100 years, nor 1,000 years. It would take you more than 73,000 years, 73 millennia. The entire history of human civilization, from the first cave paintings to the invention of the internet, spans about 10,000 to 12,000 years. You would need to repeat the history of humanity 7 times, locked in a metal can in a vacuum, just to reach the nearest star. That's a light year. It's not a measure of time. It's a ruler made of nightmare and distance. A light year is equivalent to about 9.4 trillion kilometers, and Proxima Centauri is more than 4 of them away. And the space between us and her? It's empty. It's not a void like an empty room. It's a void of almost zero density. Absolute cold, perfect silence. If you screamed into this abyss, the sound would die in your throat for lack of air to propagate it. We are isolated. Each star is an island surrounded by an ocean, so vast that it makes any physical journey virtually impossible with the physics we know today. When you look at the sky and see the nearby stars, don't just feel beauty, feel the loneliness. Those lights are beacons on unreachable islands. But Proxima Centauri is just the neighbor. She's on our block. What happens when we try to look at the rest of the city? What happens when we leave the neighborhood and look at the entire galaxy? If 4 light years already defy human logic and turn journeys into millennia-long odysseys, what about 100,000 light years? Get ready, because we've just left the balcony of our house. Now we're entering the stellar metropolis, and their numbers cease to make sense and begin to cause vertigo. Take a deep breath. We just spent 73,000 human years traveling to the nearest star. That was an exhausting journey for the mind, wasn't it? Well, the bad news is that we've barely left the front doormat. Proxima Centauri and the Sun are but 2 grains of sand on a beach that stretches beyond comprehension. Welcome to the Milky Way, our city of stars. But to call it a city is an insult to its scale. It's a continent of light floating in the dark, a barred spiral composed of somewhere between 100 and 400 billion stars. Stop and try to visualize the number billion. 1 million seconds is about 11 days. 1 billion seconds is 31 years. Now imagine 400 billion suns, each with its own planets, moons, geological histories, and perhaps even biological ones. If you tried to count every star in our galaxy, 1 per second without stopping to eat, sleep, or breathe, it would take you more than 6,000 years just to finish counting. And what is the physical size of this structure? If our solar system, that vast place that takes hours for light to travel through, were reduced to the size of a 1 real coin, the Milky Way would be the size of the continent of North America. To cross the Milky Way from one end to the other, traveling at the speed of light, that divine speed of 300,000 km/h, it would take you 100,000 years, 100,000 light years in diameter. Think about the history of our species. Modern humans, Homo sapiens, emerged approximately 300,000 years ago. Civilization, agriculture, writing, all of that is less than 12,000 years old. This means that if a caveman had lit a super powerful lantern at one end of the galaxy around the time we discovered fire, that light still wouldn't have reached even halfway to the other side. Light travels too slowly on a galactic scale. A message sent from one side of the galaxy to the other would see empires rise, fall, and turn to dust before it was delivered. The galaxy is so vast that it disconnects time. Simultaneous now does not exist on galactic scales. But where are we on this gigantic map? Many like to imagine that we are at the center, on the main stage. We are not. The solar system is located in a quiet and monotonous suburb called the Orion Arm, about 26,000 light years from the center of the galaxy. And believe me, that's a blessing. You don't want to live in the center of the Milky Way. The center of the city is a cosmic war zone. The density of stars is so high that the night would be almost as bright as the day. The radiation would fry any attempt at complex life. Supernovas explode with alarming frequency. And there in the dark heart of our spiral resides the monster, Sagittarius A, a supermassive black hole with the mass of 4 million suns. It is the gravitational anchor that helps hold the galaxy together, but it is also a devourer of worlds. We are safe here on the periphery, in the rural area of the galaxy, where life can evolve in silence. Speaking of silence, to what extent has humanity ever been heard? We often fear alien invasions. We think the entire universe is watching us. But the mathematics of distance teaches us a brutal lesson in humility. We began transmitting radio waves strong enough to escape the atmosphere. About 100 years ago, the first radio broadcasts, Hitler's speeches at the Olympics, the first TV programs. These waves travel at the speed of light, expanding in a sphere around the Earth. This is the human radiosphere. It has a radius of 100 light years. On a map of the Milky Way, which is 100,000 light years in diameter, our radiosphere is an invisible point, a pixel. If the galaxy were the size of Earth, our radio footprint, the only proof that we exist, would cover less than a city block in a small neighborhood. Any alien civilization outside this tiny bubble has no idea we're here. To 99.9999% of the Milky Way, we don't exist. We are silent. The light reflecting from our planet hasn't reached them yet. To the rest of the galaxy, Earth is still a mute prehistoric rock, and all of this is in motion. Nothing in space is static. The Earth revolves around the Sun. The Sun revolves around the center of the galaxy. We travel at a dizzying speed of 800,000 kilometers per hour in our galactic orbit. But the Milky Way is so colossal that even at that insane speed, the Sun takes about 230 million years to complete a single revolution. This is a galactic year. Let's put this into perspective. The Sun was born about 4.6 billion years ago. This means that in its entire life, our solar system has completed only 20 orbits around the galaxy. The Sun is a young adult of 20 galactic years. The last time Earth was in this exact position in its galactic orbit, humans did not exist. Mammals did not dominate the Earth. The first dinosaurs dominated the planet. The Triassic period was beginning. Pangaea, the supercontinent, was beginning to break apart. We've come full circle. And in that time, monsters emerged, reigned for millions of years, were wiped out by an asteroid. Mammals evolved, descended from the trees, built cities, and invented the internet. All this in the ticking of the galactic clock. This makes us feel small, doesn't it? A speck of dust orbiting an ordinary star, in a forgotten suburb of a galaxy among billions. But hold on to that feeling of vertigo, because so far we've only talked about our home. Our island, the Milky Way, with its 400 billion stars and spanning 100,000 light years, seems like the entire universe to us. But what happens if we take another step back? What happens when we discover that our gigantic city is not alone in the dark? What happens when we look at our neighbor, who is bigger, hungrier, and coming towards us with violent intentions? Prepare to leave the galaxy. The intergalactic void awaits us, and it's far more terrifying than the interstellar void. We left the Milky Way behind. Our home with its billions of suns is now just an island of light shining in the rearview mirror. When we leave the galactic edge, we enter a new kind of desert, the intergalactic void. Here the density of matter drops drastically. If inside a galaxy you find a few atoms per cubic centimeter, out here you can travel for years without finding a single hydrogen atom. It's absolute silence. The temperature approaches absolute zero, but if you look ahead, through that black abyss, you will see something that defies sanity. A speck of light. To the naked eye from Earth, on a very dark night, it looks like a small faint cloud, but seen from here up close it is a Leviathan. This is Andromeda, 31, the queen of our local group. If the Milky Way is 100,000 light years in diameter, Andromeda stretches for 10 to 20,000. It is twice the size. It is home to 1 trillion stars. 1 trillion, more than double the stellar population of our galaxy. And the distance? Remember when we talked about how it takes light 4 years to reach the nearest star? The light emitted from Andromeda takes 5 million years to reach our eyes. Stop and process this. When you look at Andromeda in the sky, the light that reaches your retina left that galaxy before humans even existed. Homo sapiens did not walk the Earth. Back then in Africa, our distant ancestors, Homo habilis, were just beginning to chip stones to make rudimentary tools. Throughout human evolution, the Ice Age, the discovery of fire, the building of the pyramids, the Industrial Revolution, and the Digital Age, this light has been traveling, crossing the lonely void between the two galaxies, only to end its journey by colliding with a camera sensor in your backyard tonight. Looking at Andromeda is like looking at a time before humanity. But Andromeda is not just a beautiful, distant image. It is a threat. In the universe, most galaxies are moving away from each other due to the expansion of space. But Andromeda and the Milky Way are so close, cosmically speaking, that gravity has overcome the expansion. We are trapped in a deadly dance. Andromeda is falling towards us. Right now it's moving at 110 kilometers per second. Every hour that passes, it gets 400,000 kilometers closer. Don't panic, this won't happen tomorrow, but in about 4 to 5 billion years, Earth's sky will change forever. Imagine the sight. As millennia pass, Andromeda will grow in the night sky until it fills the entire horizon. It will be larger than the full moon. Its spiral arms will shine like a second Milky Way, crossing our own. And then the collision. But it won't be a collision like two cars crashing. Galaxies are made mostly of empty space. The individual stars are so far apart that when the two galaxies merge, it's very likely that no star will physically collide with another. They will pass by each other like ghosts. The chaos will be gravitational. The sky will become a mess of light. Orbits will be hurled into deep space. Our solar system could be flung out, condemned to wander alone in the intergalactic void, or plunge towards the central supermassive black hole. Eventually, the two beautiful spirals will cease to exist. They will merge into a single giant elliptical galaxy, a bubble of old, reddish light that scientists have affectionately nicknamed Milkomeda or Lactomeda. Any civilization living on Earth, if the sun hasn't already incinerated us, will no longer see the milky band of the Milky Way. You will see a bright galactic core dominating the night sky. But the Milky Way and Andromeda aren't alone in this waltz. We're part of a club. The Local Group. Think of it as an archipelago in the middle of the ocean. The Local Group contains about 54 to 80 galaxies. Most of them are dwarf galaxies, small islands of stars that orbit the two giants, us and Andromeda, like the Magellanic Clouds. The Triangulum Galaxy, M33, is the third largest, a silent observer of the future merger of its two larger sisters. The total diameter of our Local Group is like 10 million light years. It takes 10 million years for light to travel through our neighborhood. If the Milky Way were a dinner plate on a table in Sao Paulo, Andromeda would be another plate about 6 meters away. The Local Group would be the size of the dining room. And here lies a profound existential truth. Gravity keeps the Local Group together, no matter how much the universe expands. We, Andromeda and the dwarf galaxies, will stay together forever. We are a dysfunctional family locked in the same gravitational house, but what about what's outside the house? If we look beyond the boundaries of the Local Group, gravity begins to lose the battle. Outside of Brazil, the scale jumps from millions to hundreds of millions. The Local Group, however gigantic it may seem with its 10 million light years, is just a particle, an insignificant speck of dust in a much, much larger structure. We are not an isolated archipelago. We are merely a small, peripheral neighborhood within a titanic metropolis of galaxies, a city of lights where each building contains hundreds of billions of stars. Did you think Andromeda was big? Did you think 2.5 million light years was an insurmountable distance? Prepare to have your sense of scale crushed once again. Let's leave the Local Group. Let's get to know our true cosmic state. Let's explore the Virgo supercluster and discover that our galaxy is smaller than an atom in a much larger body. If you thought feeling small was the problem, get ready to feel irrelevant. We left our Local Group behind. That family of Andromeda and the Milky Way, with their 10 million light years in diameter. On this new scale, it disappears. If the universe were a gigantic world map, the local group wouldn't be a country. It wouldn't be a city. It would be a single house on a suburban street. Welcome to the Virgo supercluster. This is our metropolitan region. Here gravity has drawn together not dozens, but thousands of galaxies. At the center of this metropolis, about 50 million light-years from us, lies the Virgo cluster proper. Their space is dense and chaotic. Galaxies collide, are shattered and devoured by gravitational monsters. At the heart of this chaos lies M87, a colossal elliptical galaxy that makes our Milky Way look like a child's toy. It was there that we photographed, for the first time in history, the shadow of a black hole, a giant with the mass of 6.5 billion suns. The Virgo supercluster is a titanic structure, 110 million light-years in diameter. Remember, light takes 1 second to travel to the moon. It takes 110 million years to cross that structure. If you were to look at the opposite edge of this supercluster, you would be seeing the light that emanated from there. At the time when the Cretaceous, dinosaurs were at their peak, long before the Chicxulub asteroid ended the party. For a long time, astronomy believed that the Virgo supercluster was the end of the line of cosmic organization. We thought it was the largest structure that existed. We were wrong, completely wrong. In 2014, a group of scientists mapped the movement of galaxies and discovered something startling. The Virgo supercluster is not an isolated object. It is merely an arm, an appendage, a suburb of something much, much larger. We live within such a vast structure that it's difficult to even name it without feeling a chill. Her name is Laniakea. In Hawaiian, it means immeasurable sky. Laniakea is not a solid object. It is a gravity basin. Imagine a region of space 520 million light-years wide. Within it, there are more than 100,000 galaxies. The Milky Way is just a speck of dust on the outermost fringe of Laniakea. We are on the edge, far from the center of the action. And what defines Laniakea? The flow. Just as rainwater flows down mountains to a river and then to the ocean, all 100,000 galaxies in Laniakea are running down. We are not standing still. We are being pulled along. There is a focal point, a mysterious place at the center of this structure, hidden behind clouds of dust from our own galaxy, in the direction of the constellation Centaurus. Astronomers call this place the Great Attractor. We don't know exactly what it is. We only know that it's a gravitational anomaly of inconceivable mass. It's the cosmic drain of our region of the universe. We, Andromeda, the Virgo cluster, all the galaxies around us, are sliding along this invisible river of gravity at hundreds of kilometers per second toward that point. But the expansion of the universe is cruel. We'll probably never get there. The space between us and the Great Attractor is stretching faster than we can fall toward it. We're running on a treadmill that's accelerating. Now zoom out one more time. Let's leave Laniakea. If you can look at the universe on that scale, the scale of billions of light years, the picture changes completely. Galaxies cease to appear as islands. They become luminous dust forming an organic structure. It looks like a sponge. It looks like a neural network. This is the cosmic web, the skeleton of the universe. Matter is not scattered randomly. It organizes itself into long filaments, bridges millions of light years long made of dark matter and gas, where galaxies are entangled like dewdrops in a spider's web. Where these filaments intersect, superclusters like Laniakea are born. They are the nodes of the network, the cities of light. But between the filaments lies the horror of nothingness. The cosmic voids, gigantic bubbles of empty space, hundreds of millions of light years in diameter, where galaxies are almost non-existent. The Boötes void, for example, a spherical abyss 330 million light years across. If the Milky Way were located at the center of the Boötes void, instead of where we are now, humanity would have looked to the sky throughout its history and seen only darkness. We wouldn't see other galaxies. We wouldn't see Andromeda. Our telescopes would point into infinite blackness. We would only have discovered that other galaxies exist in the 1960s with advanced technology. Until then, we would have been absolutely certain that our galaxy was the only thing that existed in the entire universe. we would have been cosmically alone in a way we can't even imagine. Looking at the cosmic web is looking at the greatest structure the human mind can conceive, a network of light and shadow that extends throughout the visible cosmos. But note that I said visible cosmos. There is a barrier, a final wall. It is not a wall of bricks nor of energy. It is a wall of time and causality. Up until now, we have traveled distances that light takes billions of years to travel. But the universe has an age. It is not eternal. It was born, and that imposes a strict limit. There is a point beyond which we can see nothing more. There is a horizon beyond which the light will never, ever reach us. We are trapped in a bubble of reality. What lies beyond the edge? Does the universe end there? Or does it continue forever, filled with other Laniakias, other great attractors, monsters we will never know? In the next chapter, we will reach the limit. We will walk to the edge of the observable universe, where the past becomes impenetrable, and where the expansion of space surpasses the speed of light. Prepare for the cosmic event horizon. We've reached the end of the line. We travel from Earth to the solar system, cross the Milky Way, jump to Andromeda, fly through superclusters, and navigate the cosmic web. But now, we have encountered a barrier that no spacecraft, no technology, and not even imagination can physically overcome. Welcome to the final frontier, the observable universe. Many people confuse universe with observable universe. They are not the same thing. The universe with a capital U is everything that exists. It may be infinite, we don't know. The observable universe is only the part of it that we can see. It's our bubble of reality. Why does this bubble exist? Because of a simple and cruel rule: light takes time to travel. Our universe was born 13.8 billion years ago, in the Big Bang. This means that if the light from a galaxy takes more than 13.8 billion years to reach us, we simply cannot see it. Its light is still on its way. It is beyond our horizon. Here arises a paradox that baffles many people. If the universe is 13.8 billion years old, the radius of the observable universe should be 13.8 billion light years, right? Wrong. Human intuition fails again. The real answer is far more frightening. The radius of our bubble is 46 billion light years. The total diameter is 93 billion light years. How is that possible? How did light travel 46 billion light years in just 13.8 billion years? Nothing is faster than light, right? The light didn't get faster. It was the stage that got bigger. Imagine an ant walking on the surface of a balloon as you fill it with air. The ant walks at a steady speed, but the rubber under its feet is stretching. It has covered a much greater distance than its steps would account for, because the ground has expanded as it has walked. The space between us and primordial galaxies has expanded dramatically during the journey of light. That galaxy we see as a newborn baby today is, in current reality, 46 billion light years away. We are prisoners at the center of this titanic sphere spanning 93 billion light years. And what exists at the edge of this sphere? What is the shell of the observable universe? If you point a telescope powerful enough to the bottom of the sky, scanning all the stars and galaxies, you will find a wall. Not a wall of bricks, but a wall of primordial fire. We call it the cosmic microwave background radiation, CMB. It is the oldest light in the universe. It is the echo of the Big Bang. It was emitted 380,000 years after the beginning of everything, when the universe ceased to be an opaque soup of hot plasma and became transparent. That wall we see in all directions is not the end of space. It is the end of visible time. We are looking at the universe when it was an incandescent baby. Remember that old TV static, that black and white hiss when there was no signal? About 1% of that static was this radiation. You were watching the Big Bang on your television screen. The past is literally touching you now, but there's something profoundly melancholic happening in our bubble. The universe isn't just expanding, it's accelerating. There is a mysterious force pushing space outward, acting against gravity. We call it dark energy. She is the great villain of future cosmology. Because of dark energy, distant galaxies are moving away from us faster and faster. The galaxies that are near the edge of our observable universe are, at this very moment, crossing the cosmic event horizon. They are being carried by the expansion of space at a speed greater than that of light. Remember, Relativity forbids objects from moving through space faster than light, but it doesn't forbid space from expanding faster than light. This means that the light these galaxies emit today will never ever reach us. They are being disconnected from our reality. They are leaving the stage, falling into eternal oblivion. Recent calculations reveal a terrifying number: 94% of the galaxies we can see today are, in fact, already unreachable. Even if we had a spaceship that traveled at the speed of light, and we set off today towards them, we would never reach them. The space between us and them would grow faster than our ship could travel. We are chasing mirages, ghosts of places that have already closed themselves off to us. The observable universe is an archive of things we have already lost. And the future? The future is lonely. Billions of years from now, the expansion will have pushed all other galaxies beyond our horizon. The night sky will be dark. The Virgo supercluster, Laniakea, the cosmic web, all of that will have disappeared into darkness, dragged beyond the visible edge by dark energy. Only our local group, the merger of the Milky Way and Andromeda, will remain visible, held together by local gravity. Astronomers from future civilizations, born in that era, will look at the sky and see only their own galaxy. They will not see the background radiation. They will not see the expansion. They will have no evidence of the Big Bang. They will conclude, with all the logic and science they possess, that the universe is static, eternal, and limited only to the island where they live. They will be completely wrong about the nature of the cosmos and will have no way of knowing the truth. Knowledge about the origin of the universe will be erased. We live in a golden age of cosmology. We are privileged. We live at the exact moment when the universe is old enough to have complex life, but young enough that we can still see its past and other galaxies before they escape forever. We can see the truth. We can see the immensity. But what does this vastness mean to us? To you sitting there holding your cell phone or looking at a monitor, faced with 93 billion light years, with trillions of galaxies disappearing into nothingness, what remains? Nihilism, despair, or could it be that by facing the abyss, we might find something more valuable, something that only exists here on our tiny scale? Let's go back home. Let's make the return trip and land on Earth for the final conclusion. Where science finds meaning, breathe. We took a long trip. We walked to the edge of time. We saw galaxies being swallowed by eternal darkness. We saw gravitational monsters devouring light. We saw the mathematical coldness of a cosmos that, at first glance, seems indifferent to our existence. Faced with a diameter of 93 billion light years, faced with trillions of worlds, the human ego is not only shattered, it is pulverized. Science has shown us that we are not the center. We are not the reason. The universe was not made for us. If the history of the cosmos were a 2-hour movie, humanity would only appear in the last fraction of the last frame of the end credits. This can generate fear. This can create the feeling that nothing matters. After all, if we are just dust on a forgotten rock, why would our pains, loves, and achievements have any value? But now I need you to change your perspective. Let's reverse the logic. The vastness of the universe does not diminish the Earth. The vastness of the universe is what makes Earth the most precious place that exists. On February 14, 1990, the Voyager 1 probe was 6 billion kilometers from home. It had completed its primary mission. It was about to turn off its cameras forever and navigate the silence of interstellar space. But at the request of astrophysicist Carl Sagan, NASA sent one last command. Turn around, look back. Take a picture of home. The image she sent is grainy, full of noise. Rays of sunlight scattered by the camera lens obscure the view. But if you look carefully in the middle of one of those sunbeams, there is a spot, smaller than a pixel, a speck of bluish light suspended in the void. That point is here. That point is our home. That point is us. Pense na escala que acabamos de explorar. The void of Bootes, the great attractor, the walls of galaxies. In all these places we saw fire, radiation, gravity, ice, and stone. We've seen nuclear physics. We've seen celestial mechanics. But we didn't see any meaning in it. Our star doesn't know it's a star. A black hole doesn't know it's powerful. A galaxy doesn't feel loneliness. Matter by itself is mute. But in that grain of blue dust, something miraculous happened. The matter has sparked interest. Atoms forged in the hearts of dead stars organized themselves in such a complex way that they began to think. They began to feel, they began to wonder, where did I come from? We are the universe observing itself. We are the way the cosmos has found to know itself. Without us, nor beings like us, the universe would be just a gigantic, empty stage, a theater without an audience, an invisible beauty. The magnitude of space needs consciousness to be witnessed. Look at that spot again. All the people you've ever loved, all the people you've ever hated, every king and peasant, every hero and coward, every creator and destroyer of civilizations, every mother, every father, every hopeful child, every inventor, every explorer, every teacher of morals, all the superiors, all the dictators, all the saints and sinners in the history of our species lived there, in a grain of dust suspended in a ray of sunlight. Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by generals and emperors so that, in glory and triumph, they could become the momentary owners of a fraction of that point. Consider the endless cruelties inflicted by the inhabitants of one corner of this pixel upon the almost indistinguishable inhabitants of some other corner. How frequent are their misunderstandings? How eager they are to kill each other? How fervent are their hatreds? Our attitudes, our supposed self-importance, the illusion that we have a privileged position in the universe. All of this is challenged by this pale point of light. And here lies the great irony of the scale. Scarcity creates value. If diamonds were as common as sand, they would be worthless. In the universe, what is common? Empty space is common. Hydrogen gas is common. Dead rocks are common. Exploding stars are common. What is rare? Life complexity, the capacity to love, music, curiosity. As far as we know, in our 100 light-year radiosphere, in our 100,000 light-year galaxy, perhaps even in our supercluster, we may be the only ones. We may be the only flame of consciousness burning in the darkness. This doesn't make us small. It makes us responsible. We are the guardians of meaning. If we destroy ourselves, if we allow our little island to be consumed by war, ecological negligence, or ignorance, the universe will not cry. The universe won't even notice. It will continue its blind and silent expansion. But the light of consciousness will be extinguished in this corner of the galaxy, and silence will reign once more. The distance of light years doesn't exist to humiliate us. It exists to protect us. The space between the stars is the quarantine that allowed life on Earth to evolve without being disturbed by cosmic cataclysms every Tuesday. We were lucky. We won the most improbable cosmic lottery of all. You, specifically, are the result of an unbroken chain of survivors stretching back 4 billion years. Your ancestors survived meteors, ice ages, volcanoes, and predators so that you could be here now, holding a device made of minerals and electricity, contemplating the vastness. So how big is the universe? It is large enough to contain all possibilities, but it's empty enough that we are special. When you look at the sky tonight, don't just see impossible distances. Don't just feel the weight of light years. Feel the connection. The atoms in your body were cooked in the same nuclear furnaces that created those distant stars. The iron in your blood came from the death of supernovas. The calcium in your bones came from the collapse of ancient stars. You are not in the universe. You are the universe. You are a part of him that gained legs, eyes, and a mind. We are travelers. We started in Africa, crossed oceans, conquered the sky, and set foot on the moon. Now, the stars are calling us. The distance is brutal. The speed of light is a cruel limit. The expansion of space is a race against time. But look where we've come. Look at what we've discovered. Perhaps we will never leave the Milky Way. Perhaps we will never reach Laniakea. But as long as there are humans looking up, asking questions, the universe will not be dark. It will be illuminated by our curiosity. The universe is vast. Life is rare. Time is short. Make it worthwhile. Take care of this pale blue dot. It's the only home we'll ever know. Now I ask you to subscribe to the channel and leave a like on the video, and watch the next video about light years, which will leave you even more amazed.